All right, so good morning everyone. Let's continue our discussion. We'll start talking about int, okay, another data type, right? So this int is same as int of your Java, okay? When we say same, that means they can store similar values, right? So remember one thing, any arithmetic operation that you do in Java or Scala will ultimately give you integer, which means if you have A, if you have B, okay, and if this A is of byte type, if this B is also a byte type or character type, whatever it is, when you do arithmetic operation like plus, minus, into, divide, modulo and all, it always gives you a integer. Okay, so that's the first rule that you need to understand. And by default, the numeric data type is always of int type. That means if you write val x is equal to 10, then this 10 is numeric, so this is automatically integer, right? If you want to be a little specific, if you want to say, hey, no, this x should be a byte type or short type or should be of long type, then you'll have to explicitly write like this, right? Otherwise, if you just declare a variable like this, then by default it will always be treated as integer. Okay, that's important for every one of us to understand this. So let's move on. We'll start with the notes. The notes says any whole number is by default treated as integer if it falls within the range. Okay, which means let's say val x of integer is equal to 10. When you do this, then since this 10 always falls within the range of integer, it will always be treated as int, integer. Okay, if you don't write int, then also it will be treated as integer only. Let's go to our REPL as well. So let's say val x is equal to 10, this is integer, or you say val x of int is equal to 10, this is also integer, right? Now what if I write something like this, x of integer is equal to 0x12. Okay, this is how you actually represent a hexadecimal value, and we have already discussed what is a hexadecimal, right? Hexadecimal means it follows the pattern of 0 to 15. Hexadecimal has 16 different numbers, 0 to 15, right? When you say 12, what is this 12? See, till 9 it is okay, right? 10, 11, 12. So when you say 12, now if you convert this to integer, then what you get? You get 18. Okay, so how do you get 18? Let's see. You have 12, so you write 12. And since this is hexadecimal, that means base is 16. 16 to the power 0, 16 to the power 1, right? So 16 to the power 0 is 1. So 1 into 2 is 2. And 16 to the power 1 is 16. And you add these two. 16 plus 2 is 18. And hence the decimal value of 0x12 is 18. And that's what you got here. Okay, so let's go back. All right, now let's move on. So the next thing is, what if I write val x of integer is equal to a? Val x of int is equal to a. If you do this, then what you get is 65. And why are you getting 65 here? Because we've already discussed that every character in the world are assigned a ASCII code, right? So ASCII code were old format, but now they have all been moved to Unicode, wherein the A to Z, capital A to Z, small a to Z, they have same ASCII and Unicode. That means in computer system, every characters are given a number, right? So capital A is 65 and hence you got here 65. Okay, now let's try something like this. Val x of int is equal to 0, 1, 2. When I say val x is equal to 0, 1, 2, okay, it is 12. Let's say 15, it is 15. So earlier in the previous version of Scala, okay, when you used to write 0, 12, it used to treat this as octal, okay, but now it does not treat it as octal anymore. It will be just treated as an integer. Okay, so when you say 0, 15, it's giving you 15. But if you go back to the older version of Scala, I don't remember the exact version, okay, because I have been teaching Scala since last 6-7 years. So if you look into the previous version of Scala, this is actually an octal number, but no more, okay. Now Scala says if you write 0, 12, I'll treat that as an integer itself. So how do you represent octal? We will talk about that later, okay. All right. Now, if you ask me, hey, what is the maximum value of byte or what is the minimum value of byte, right? So in that case, what you need to understand is 1 byte is equal to 8 bit. So 8 bit probably means minus 2 to the power 7 to 2 to the power 7 minus 1. That's the formula of byte, is not it? Let me repeat this again. So if you ask me what is the maximum and minimum value of byte, then you need to understand 1 byte is equal to 8 bit, okay. And if 1 byte is equal to 8 bit, then the formula goes like this. Minimum value would be minus 2 to the power 7 to 2 to the power 7 minus 1, right? So likewise, so you can find the byte, you can just write byte dot, can I check if I have max, give a tag. See here, a byte class has a variable called maxval, which gives you the maximum value of the byte, that is 127. Similarly, do I have something like minval? Minus 128. So you can find out what is the minimum value and maximum value of a data type by following this approach. Just call this method maxval, minval. These are not methods, sorry, these are actually a constants, okay. Now likewise, what you can do is, if you want to find for integer, you can do the same thing, integer dot minval. It gives you the minimum value that an integer can store, okay. Similarly, integer dot max value, it gives you the maximum value that an integer can store, okay. Now what if I say integer dot maxval plus 1? So what are you trying to do here? You got a maximum value and you are doing an arithmetic operation here, plus 1. Plus 1 will always result in what? Integer, right? But maximum value is what? 647. Can I go beyond 647? No, I cannot go beyond 647. If you cannot go beyond 647, then what happens? It goes to the cycle. Remember that cycle what we had, right? We discussed a cycle with a byte. The cycle holds good equally for integer as well, right? The only difference is the range has now changed, okay. So you got here what? Minus, it took you to the negative cycle, okay. What if I do integer dot maxval plus integer dot maxval? What if I say integer dot max value plus integer dot max value? That means you are trying to add two big number. You're trying to add this number plus another big number. So ultimately it gave me minus 2. Why? Remember that formula, modulo formula? The same formula is applicable here also. The only difference is the range, right? So it goes through that cycle, it goes through that formula and it gives you minus 2. Okay. Now you can also represent number in underscore format. That's amazing, right? Which you do not see in Java. Okay. So just say, well, x is equal to 2500. Now see here, it gives you 2500. Interestingly, this x is of integer type. See here, you're using underscore. Okay. Now similarly, let's try something like this. Well, x is equal to 2500. Okay, which means probably, let's say this is how I want to represent my number, 2500, and let's say 00.6 probably, okay. So when you do that, it just gives you this. It does not give you dot, okay. Remember one thing. So for example, if I say I have 10 lakh rupees in my account, so probably I would write something like this, 100,000, 10,000, lakh, 10 lakh, right? This is what I'll write, right? But then I want to follow some pattern, probably like this, 10 lakhs. Okay, if you see, this looks little readable than the other number altogether. Okay, what the use case? See, it's all about readability. You want to use it like this, you can use it like this. Okay, now representing octal is deprecated now, but why? Right? So see here, because in practice the programmer does not use them as well as it causes confusion. For example, 0, 1, 2 is equal to 10 will be true, but it looks confusing. So for example, see, if you see this 0, 1, 2, if I say this is an octal number, and what is the decimal equivalent of it? The decimal equivalent of it is 10. Okay, this is true. But then if you try to compare this, then it looks a little confusing. And because it looks a little confusing, That's the reason the octal is deprecated. But if you still want to say, I want to represent that with octal, then what you can do is you have another class called big integer. Okay, that can be still used to represent the octal number or hexadecimal number. Check this out. So let's say, well, x is equal to big integer, and I'm saying I want to represent this 12 in a octal format. Okay, then what it gives you? It gives you 10. The octal format of 12 is 10. Similarly, if I say I want to represent this with 16, that means hexadecimal, then it's 18. Okay, likewise. Okay, now let's look into this. Well, x is equal to 9222, a big number, right? Can I actually write something like this? So let me try this out, because I'm not going to type this big number. I'll say copy and let me put it here. Okay, it says, well, x is equal to this big number is too large. It says I will not be able to hold this value altogether. But if your requirement says you need to hold these big values as well, then what you should do is you should basically go and say L. When you write just L, it means I want to represent this as a long. So what is the difference between integer and long? The difference between integer and long is integer can store smaller values, whereas your long can store literally large value. It's something like this. What is the difference between 5-liter container and 50-liter container, right? Both are same. Both can be used to store milk. Both can be used to store water. The only difference is the capacity, right? So likewise, your x, if it is integer, can store lesser value, and if it is long, can store larger values. Okay, now integer dividing by 0, it's very important. Okay, so whenever you try to divide an integer by 0, it will always give you arithmetic exception. When you are learning any programming language, it is equally very important to learn about the exceptions, because as a programmer you will have to stay with exceptions all over the time. Many times things breaks in the production. The first thing that we do is go to the log file and check the exception. And if you don't study exception, you will not be able to understand what is happening. A lot of people come back to me saying that, Suraj, I'm actually working in this particular stuff, and somehow I'm facing this exception. Can you tell me what is the problem? The problem is you have not learned how to study the exception. If you study the exception, you will be able to solve the problem within no time. Okay, let's check this out. So 10 divided by 0 will always give you arithmetic exception. Okay, so just say, well, x is equal to 10 by 0, and this gives you exception which says, hey, dividing by 0 is not allowed. Okay, now let's move to the next topic, that is long. And as I told you, the difference between integer and long is the way it stores the value. You can think about integer as your car, and you can think long as a bus. What is the common thing? Both carries passenger. What is the difference? Bus can carry more number of people, right? Likewise, if you feel the integer is not enough to hold the value, then you can go ahead with long, right? But we use long rarely in the production unless the situation demands. For example, if you say, I want to store probably the bank balance of a customer, and let us assume there is no concept of paisa, right? It's only rupees. It's like 50,000. It's not 50,000.50 paisa. I'm just giving an example. If you are sure that you are going to store only integer part and you don't care about the decimal value, then you can go ahead with long if integer is not enough. It depends on the use case. Okay, so let's talk about this now. Here, let me say byte dot max value, byte dot min value. So which means if you want to store, let's say, a student's roll number, and let's assume there is a hard rule that no section will have more than 100 students. That the promise the school has made. So in that case, probably a byte is enough. It's not it. But let's say, let's look into solve. Capital S. Okay. Now let's say you want to store the salary of a fresher in a MNC, and let's assume nobody pays more than 30,000 to a fresher at any given condition. Okay, and if you want to store their salary, and I'm assuming that the salary does not go in a decimal value. If that's the case, then you would probably use sort. Why? Because sort can hold maximum 32767, which means I can say, well, salary of sort type is equal to, maybe let's say my salary is 25,000. This is perfectly fine. Okay. Similarly, let's say you are storing some number, and let's say the sequence will be under this value, right? So if that's the case, then you can use integer to hold that value. Okay. But if you assume that you're working for a big company and wherein there is a lot of transaction happening every day, and you want to store the transaction ID, and let us assume the transaction ID cannot be accommodated in this integer.max. Well, let's say the transaction ID may go little bit more, then probably integer is not sufficient. In that case, you'll start long. Why? Because the long can store this much value, right? So if you say, if you want to store probably your salary, right, and if you're 200% sure that your salary will not exceed this anytime, then you can go ahead with your long. Are we clear, guys, when to use long? Right. So remember, you have so many data types just because every data type comes with its own memory footprint, right? For example, a long takes 8 bytes, is not it? Whereas your byte takes only 1 byte. So think about this: millions of long versus million of a byte. You'll be saving a lot of memory, right? And also remember one thing: these programming languages were built in those days where memory were very costly. It was expensive. Today also it is expensive, but then these programming languages were written when we had only 256 MB or 512 MB of RAM. Today we have around 64 GB of RAM, 128 GB of RAM itself. So in order to optimize the memory, okay, a lot of data types were introduced so that programmer can choose whatever works well for them. Okay. Having said that, okay, whenever you want to work with integer kind of data, by default we always go to integer. We don't use byte. Even if the range is enough, the industry standard is always stick to integer, even if you want to store 10. Okay. All right, let's move on. Okay, now look into this. Long dot max value will give you this big number. Long dot max value plus 1 will take you to the negative cycle again. Okay, long dot max value plus long dot max value, when you add this max value 2 times, then it gives you -2. Why? Because adding those two numbers gives you a big number, and then think about that cycle, right? It follows that pattern, it follows that cycle, and ultimately settles down to -2. Okay. Likewise, long dot max value into long dot max value, that is huge again, right? So this value into this value again will be huge, but it still follows the same pattern and somewhere settle down to 1. Now let's talk about float. Okay, so float can be used when you want to store decimal values, right? For example, if you say, hey, I want to store the salary of the people, the bank balance of the people, and let's say we also have the concept of paise, which means I can have, let's say 10,000 rupees 50 paisa, right? If you want to store the decimal part as well, right, then you can actually go ahead with float. Okay, so to store decimal values, you have two data types. They are float and double. Okay, now let's try this out. I'll say, well, x is equal to 5.0. If I say, well, x is equal to 5.0, then it by default gives you a double. So remember, for the numeric type, the default data type is integer, right? Which means if you perform any operations, it ultimately gives you integer. Likewise, for decimal kind of values, the default is always double and not float. Okay. However, if you want to get the float, then you should write f. You can either write small f or you can write capital F. Okay. So if you want to be very specific that I want this to be a float type, then you will have to specify with a small f or capital F, which gives you a floating value. Okay. What if I do something like this? Can I not do something like this? X of float is equal to 5.0. Okay. Well, x of float is equal to 5.0. So double getting assigned to float in Scala 2.x. So if you look into this, this means you'll get this problem, you'll get exception here if you are using Scala 2.x. Okay, in Scala 3 this is valid. So likewise, there are small like improvisation on Scala 3 then Scala 2, and we will be talking about every improvisation as we move on. Okay, the beautiful thing that you'll get when you learn Scala from me is, since I was teaching Scala 2 and now we have moved to Scala 3, we will be able to figure out what all worked last time and did not work today, and what all did not work last time it worked today. Okay, so this is perfectly valid in Scala 3 but not valid in Scala 2. Okay, all right. Now you can also do something like this. You can say, well, x of float type is equal to 5.o dot to float. You can still do this. Okay, if you're using Scala 2, then by default this is double, and that double can be converted to a float. Okay, can I do something like this? What if I don't write dot o and just say to float? Is there anything as such? Yes, it is. Which means if you're given an integer and if you want to convert that to float, you could actually do something like this. Now let's try to link it up. What if I have, well, x is equal to 10? Okay, now let's say I want to convert this to a float and store it in a variable y. Well, y is equal to x dot to float. Okay, hit enter, and what I got is I got 10.o, right? So this is how the conversion can happen. Okay, now one thing that you need to understand is, if you divide integer by 0, it gives you an error. But that's not the case with float and double. Okay, let's check this out. I'll say, well, x is equal to minus 5 by 0.0. Now, if you look into this expression, okay, what is your minus 5, guys? What is the data type of minus 5? Data type of minus 5 is integer. What the data type of 0.0? Not float, double, right? So the data type is double. This is double. Okay, so since it is double, what will happen is this whole output would be of double type. But if you try to divide a number by 0.0, it will give you infinity. And why did I get minus? Because here is a minus symbol. If you change this symbol, if you remove this minus, if you just say like this, then it gives you infinity. Clear? So if you see, well, x is equal to 5 by 0.0 gave me infinity, but this infinity is of double type. Okay, now let me also try something like this. What if I say minus f? I'm saying, okay, I want to divide minus 5 by 0.0 f. Now the moment you write f, this is treated as what? A float, not a double anymore, right? So this will also give you infinity. This minus symbol is because of this, but if you look into the data type, this is a float infinity. Okay, this concept is applicable for Java as well. Okay, well, x is equal to, if you write something like this, this also gives you minus infinity of float type. Okay, so I've written here, note the space between slash and this. So what if I don't give a space here? Then it would not be able to differentiate what exactly you are trying to do. Okay, so that's the reason we have given a space, and all these small things actually matters a lot, right? Check it out. Well, x is equal to minus 5 by 0.0 f. Now what is this f? This f is basically float, and you are trying to divide this number by 0.0 float, which will always give me infinity, but since there is a minus symbol here, the result is infinity. Okay, similarly, if I say float dot max value plus float dot max value, this will give me infinity, and that was not the case with your integer type of data, right? If you remember, in integer, when you were doing max plus max, there was a concept of cycle, and it was giving me the output, right? So in this case, that's not the case. Let's say into, this also gives me infinity. Okay, so let's check what is the maximum value of this. The maximum value of this is 3.4028235 E38. what is the meaning of this, we will see that. Okay, now similarly, let's try max value plus 100. Okay, it is actually giving me something very similar. Okay, keep doing this, it will give you something very similar, but one time will come when it says, hey, looks like I cannot hold beyond this, and then it will throw you infinity. Okay, now let's talk about this. What is the meaning of this value? That's very important for us to understand. Okay, so let me just write it on the board first. I just wanted to tell you what is the meaning of this. Okay, so this is the maximum value of double, and this is the maximum value of float. So before I explain you this, let me show you one small example. Okay, I'll just go back to the screen. Okay, and let me just write 0.4 E2. I'm just writing 3.4 E2. Okay, and let's see what the output of this. The output of this is 340. If I write 4, then I got 34,000. Okay, so 3.4 E4 gave me 34,000. Let me copy it down. Okay, so look into this. This gave me 34,000, which means, can I say, looks like 3.4, this E looks like 10 to the power 10 to the power 4 is 10,000. 10,000 into 3.4 is 34,000. Now, let us try to understand, what do you think would be the range of this float? How much value a float can store? Float can store the value like this: 3.4 into 10 to the power 38. Okay, so this is the value a float can store. That means the maximum value a float can store is this, right? Similarly, if you ask me for double, it would be 1.7 into 10 to the power 308. It was just 38. I just wrote it for 38. But this is 308, which means almost 10 times, right? So I'll have to copy paste this 10 times to show you the maximum value that a double can store. Okay, now think about this. The maximum value of a double and the maximum value of long is very different, and this is the reason why a float can store a larger value than double. Okay, we will talk about those in the coming days in more details. I'll also teach you how internally the float actually stores the value. Okay, all right, so let's look into this. Any operation with float and lower data type will always result in float. Any operation with double and lower data type will result in double, which means if you're performing operations on float and integer, the output will always be float. If you perform any operations on double and integer, the output will always be double, because both of this has more privilege than the lower data type. Okay, we will talk about that in typecasting chapter. Okay, next, expression without assignment. So we have done this so many times, but let me show you this again. Okay, what happens when you just quickly say 5 plus 10? It gives you 15, right? But look into this, 5 is actually integer. Okay, and 5 is a number, integer by default, and it has a method called plus, taking another integer. So when you write this, it actually means you are saying 5 dot plus is a method. Okay, and I'll pass 10. This is what is happening internally and giving you 15. So the plus is literally not an operator, it's actually a method in Scala. So 5 dot plus of 10 gets evaluated, which returns an integer, that is 15. Okay, it gets assigned to a variable res1. In my example, if you see, 5 plus 10, we got 15, but that's assigned to a variable called result 24. Okay, you can refer to res later in your program. When you are doing it on REPL, this is what happens. Okay, so you can actually access this res24, res25. Okay, if you want to print, you can just say print res1. It gets printed. Okay, if you write the expression again, it again gets calculated and gets assigned to next series variable, that is res2. So I've got res26, right? Now if I say okay, I'll say res24, 24 means 15 plus 30. If I do one more operation, then this will be again calculated, and it is actually getting assigned to a temporary variable 27. Okay, however, if I write var or val x is equal to. Then in this case, a new variable res28 was not created, which means when you are actually writing a code in REPL, okay, and if you don't assign it to any variable, if you have written an expression and that expression is not stored in any variable, then your REPL automatically gives you a temporary variable wherein the output is stored, and you can access that variable as well. That's what we have been doing. Now see here, 5 plus 10 is 15, okay, and it again gets assigned to next variable res3 as per this notes, right? Let me do what? Let me quit my terminal. I have come out of Scala, right? Now let me again say Scala. I'm back with another new session, and let me say 10 plus 5, 15. Okay, again it started with res0. Okay, I'll again write 10 plus 5, and it was assigned to res1 and so on. So this keeps going. Okay, as you open a new terminal, it starts with res0, and every assignment that you do, if you don't assign it to a variable, then it ultimately assigns you a temporary variable. Okay, all right. Okay, now also let's check one more thing. What if I want to print this res1? Okay, I'll say print res1. It printed 15. Let me again try 10 plus 5. Okay, now in this case I got res0, res1 and res2. But in our Scala's version, what used to happen, this print method itself was getting assigned to another variable. Okay, so print method returns you unit, and that unit was assigned to a variable, temporary variable. But that's not the case in Scala 3. Okay, all right. Now let's talk about double. So by default, every floating value is treated as double unless you suffix f, small f or capital F at the end of the number. Okay, which means if I say where salary is equal to 5000 D, if I write D, that means it is double. Okay, if I write capital D, then also it is double. What if I don't write D? Then if I don't write D, then by default it is integer. It's not it. Similarly, what if I write F? If I write F, then it is a float. If I write capital F, it is a float. Okay, so if you want to represent double, then you can either use small d or capital D. If you want to represent float, you can say small f or capital F. Now let me try something like this, where salary is equal to 5000. Okay, so I got a salary which is of integer type because 5000 looks like a number, and I did not say f or d, right? Now it's a variable, that means its value can be changed, of course, right? So let me say salary is equal to 5000 f. Can I do this? You cannot do this. Why? Because the salary is already of integer type, and if it is already of integer type, you cannot force to hold a float value now. That's wrong, practically wrong. Okay, now again let's do this. I'll say variable num1 is equal to 0.0. Now what is the data type? As we know, if you write a decimal and if you don't write anything, by default it would be double. Okay, if I say f, then it is a float, right? Similarly, if I say 2e3, that means 2 into 10 to the power 3. 10 to the power 3 is 1000. 1000 into 2 is 2000. That's what you should be expecting. But since you have written it in this notation, it will be treated as double, not integer. Similarly, let me try something like this. What if I say 2e2f? When I say 2e2f, it gave me 200. Why? Because e to the power 2 is what? 10 to the power 2. 10 to the power 2 is 100. Right? 100 into 2 is 200. And this f means float. So you should not be confused when you see a statement like this. 2e2f is 2000.o, but it is of float type. Okay. Similarly, what if I write where number 1 is equal to just 0.2? I have not written 0.2. I just wrote 0.2. If you say 0.2, it is understood that it is 0.2. And since you have not written f, by default it is double. Okay. Now again let's do something like this. What if I say 0.1 plus 0.1? So you are actually adding two doubles. Remember, this is not float. These are two doubles. So when you add two doubles, the result should always be double, of course. Okay, similarly, if I do 0.1 plus 0.2, it gives me 0.300004. This is interesting. It did not give me 0.3, right? So we will talk about this in the coming chapter. Okay, why it gives you the output like this.